Okay, so I think we can go ahead and get started. My name is Dulcie. I am the head of data science at DataKind UK, and I am really excited to be joined today by Michelle and Nick, who are going to share some of our learnings about the rapid developments that have taken place over the last couple of years in generative AI, and to think about some of the use cases for the third sector. And we're very grateful for the Insight Infrastructure team at Joseph Rowntree Foundation for making this possible. So just a few reminders. We are recording the session today, and we will share the recording and the slides with all of the participants. If you do have a question, you should see the Q&A icon at the bottom of your screen. Please feel free to ask any and all questions. We'll have lots of time for questions at the end. We do have closed captions are enabled, and if you do have any additional accessibility needs, please do let us know. The best way to do that is to reach out to Nicole Holgate from the DataKind UK team in the chat. Okay, so we're going to go ahead and get started. I'm just going to end the poll. It looks like most folks have had a chance to fill that in, but we wanted to know, are you or your organization currently using generative AI tools in your day-to-day work, and what are you using it for? And then we'll talk a little bit about what some of these tools are. So just going to share the results so everybody can see. So it looks like about a third of people are not really using generative AI tools in their day-to-day work, totally fine. But about half of people are informally trying things out, and a smaller percentage are using this day-to-day. In terms of what it's being used for, lots of folks using it for kind of comms and marketing and administrative tasks like summarizing meetings, drafting emails. Some people for fundraising grant applications, and for internal knowledge management, such as an internal chatbot. We'll talk a little bit about that later. Few folks using it for something else. I would love to know what that is. If you are somebody who said that you're using these tools for something else, please tell us a bit about what that is in the chat, so we can all be a bit more informed and inspired. That's great. So just to get us started, this is the first webinar in a series of events that we're running around generative AI. I know there's been a number of really excellent events in the sector around different opportunities for using GenAI tools, especially around content creation or as a digital assistant. But we found at DataKind UK that we're increasingly getting questions about how to use these tools to get more out of their data, and how to operationalize some of the thinking about ethical challenges raised by these tools. So we are really excited to be partnering with the Insight Infrastructure team at JRF to deliver a series around this. Today is going to be the first one, looking at what GenAI is and how you can use it beyond the kind of email summarization, which it is very helpful for. And we'll tell you a little bit more about how these tools work under the hood, which is going to be really key to help you understand what the risks and limitations are. In about a month's time, we're going to dive more deeply into the use cases. How do you think about what a relevant use case is for your organization, and how do you mitigate some of those risks? So if there's a use case that you hear about today that you'd like us to go into a bit more depth about, please let us know when you sign up for that event. And then later in June, we're going to have a session talking about creating an AI policy with some experts who've done that at their own organizations. And once again, I just want to say thanks to the Insight Infrastructure program. This program was developed by the Joseph Rowntree Foundation, and they aim to democratize access to high quality quantitative and qualitative data and evidence through open collaboration and innovation to help us tackle injustice and inequality throughout the UK. So today we'll talk about what GenAI is. While we're doing that, we're going to talk a little bit about the history of AI and how models like the large language models actually work. This is not to scare anybody. I genuinely think that everyone can get a good conceptual understanding of how these models work. And I think that that's really critical to understand what they're good for and what they're not good for and what the risks are. Once you have this understanding, we're going to talk about a bit more about some of the risks and how they can be mitigated, and crucially, some of the practical use cases of how others have used these tools in the sector. Again, we're going to have lots of time for Q&A, so please post your questions in the Q&A section. If you do have a kind of clarification question about something that's not clear, we will do our best to tackle that as we go, but otherwise we're going to have a lot of time at the end of the webinar to hear from our expert panelists about those questions. And once again, if you do have any accessibility needs, please send a message to Nicole Holgate from the DataKind UK team. So importantly, I'd like to introduce our other speakers who are both long-term volunteers with DataKind UK and have worked with our ethics committee. So first off is Michelle Lee. Michelle is a director in the deployment team at Wovenlight, which is a category-defining private equity firm that's powered by cutting-edge AI and expertise in real-world deployment. And at Wellcome, she currently leads the private equity roundtable on responsible AI and co-develops policies and guidelines around safe and scalable use of AI. Michelle has completed her PhD at Cambridge in computer science, and she was focusing on mitigating unintended biases in AI systems. So really grateful to have her here today. And also really grateful to have Nick Soros here. So Nick is the CTO of MantisNLP, and MantisNLP is a data science consultancy that focuses on GenAI with a remote-first culture, and they have clients around the world. Nick has more than 10 years of experience working as a data scientist in a range of industries in places like the Wellcome Trust and different startups at various stages of data maturity. So again, so pleased to have both of them here. And also great to see such a diverse audience as well. And then lastly, in terms of introductions, just a little bit about DataKind UK. So for those of you who don't know us, we are a small charity who has a vision of a strong, thriving third sector that embraces data use to become more impactful. We have existed since 2013, and we provide a range of support to the sector. We've worked with almost 300 different charities on a range of different projects, with one-to-one data projects to help them help organizations tackle their data challenges by supporting communities for data users in the sector to learn from their peers, and by providing sort of short-term advice and support and guidance that help people learn what's possible with their data. And we're able to do all of this because of our volunteer community. So we have wonderful volunteers like Michelle and Nick give their time and their expertise to our partner organizations. So let's start off. I am going to pass over to Nick, and he's going to tell us a little bit about what generative AI is and how it evolved.
Thanks, Dulcie. Are you going to be moving the slides for me, or I can control them? You are. Okay, cool. So hi, everyone. Really excited to be here. So we thought we'd start, as Dulcie said, with some explanation of what GenAI is, and I think the best way to do that is if we tackle a little bit these two terms of the generative AI phrase and essentially try to understand how we got from one to the other. So starting from the generative part, which is probably the easy one, this is simply to say that generative AI is a subset of the entire AI field. It has to do with generating content, things like, text when you're interacting with ChatGPT, or images, as you've seen DALL-E and other models create, videos lately, and any sort of form of data. This is in contrast to, for example, if you had an AI system recommend you a video, or if you had an AI system predict, whether you should take a loan. The generative part of AI is sort of generating something like, as I said, text, images, or videos. We'll go to the next one. The other part of the generative AI puzzle, of course, is the AI, and through this first section of slides, we're going to be going from, how we got from the AI part to the GenAI part, right? So as you can see, AI is a broader field. It encompasses a couple of different other terms that we will explain. But AI itself is, our effort to sort of replicate things that we tend to associate with humans. Things like our ability to see things and recognize, objects and converse with each other. Identify, like the tone of someone else, its sentiment, things like that, and like move around and do human-like things. So when AI started, as I sort of hinted, then like in a very scientific sort of manner, it was split into subfields uh, to study the different things that we humans do. Such as our ability to see became a field on its own called computer vision, our ability to converse, natural language processing, and so on and so forth. And each of those also sort of split into subfields as well. As I was sort of describing earlier, our ability to recognize objects became a track on its own for computer vision, or identifying the sentiment of the words we say, it became something completely different. If we go to the next slide. And it's worth saying that during the years that we're attacking, first of all, it's worth saying AI is not a new field. So it started around the same time as computers started, so 1950. And it has gone through phases like the one we're experiencing now, where there was a lot of, promise that, AI is going to change the world. And there were at least two times where those sort of expectations sort of collapsed, the so-called AI winters. Now, it's worth saying that all of those fields I mentioned earlier, we were making a lot of progress on those in the first two eras of AI until 1990s. We were making a lot of progress on those areas independently, mainly by trying to break things a little bit apart, create so essentially break the bigger puzzle into smaller pieces and try to make progress on smaller pieces, with the hope that when you combine everything together, you would get something intelligent back. So a lot of that effort, ended up in, systems like Deep Blue, which wasn't, entirely, smart on its own. It was sort of was doing a lot of search at scale, or, things like the Jeopardy system from IBM as well, that similarly it was representing a lot of knowledge in, like a large data center, and was able to answer questions. But all of which is to say, at around 1990, this whole paradigm switched into a different way to do AI, which was based on the idea that instead of trying to, break things apart and, trying to understand sub pieces together and bring them, combine them to create intelligence, we could potentially attack the whole system end to end, and try to create a way for computers to learn in the same way that we humans learn, from the data we have around us, from the images we see, from the sort of interactions we have with each other, the text we've written. So this leads us to the machine learning part of AI, which represents one aspect of solving, the AI puzzle. Like, how can we create human-like things? It's, as I said, this part that sort of relies on this idea. We can create some sort of learning process instead of understanding, breaking down, how an image comes into our eyes, and then, detect a specific sort of thing of interest and how this is processed. We're trying to just create a system that can learn from a lot of those data and do a task that we're interested in, like the things we said previously, like see things and identify objects, or understand the sentiment in a text. So the most common way we're doing that in machine learning was a process called supervised learning. So supervised learning is essentially a collection of is a process where we do know the end result we want to get from that learning process. So, for example, in this case, we want to identify, what type of biscuits these are. So we do have these sort of labels associated with our data. In the case of text, it could be the sentiment of the text. In the case of robotics, it could be, where the robot needs to move. But in any case, we would need to have what is the objective, the task that we're trying to emulate. We would have these sort of labels, and then we would teach the system specifically to emulate that to identify or do that label essentially. It's worth saying, like, other than this was and is the dominant form of machine learning, and this is what has led us all the way to where we are now. It's worth understanding a little bit how it works, I'd say. And the way this works is like on a very high level, of course. If we go to the next slide, Dulcie, is nothing super complicated. Is basically, we have if we have a way to predict or generate, as we do nowadays, that label from one model we've created, then we're going to be giving that feedback back to that model. Like in this case, for example, if we give an image of, a bourbon cookie, and, like we get back from the model, however we've coded it, maybe, we've said, if it has this color or if it has this shape, then you need to say that thing. Then we say this is completely wrong, essentially, and we move on to do a next iteration where we're trying to get the model to predict something else. It's a little bit less wrong, and we're doing that iteratively until it gets the answer right, essentially. And this is how the model eventually learns, that this is the correct thing. By trying things and slowly going closer into predicting kind of like the label we gave it in the beginning. This is in contrast to another sort of area of machine learning, like another way to learn, and that applies sometimes in many projects we do, which is without data at all. So, for example, you might have a lot of data yourselves in your respective charities, and you often say, like, what does this data say about either the funding behaviors or what, like a survey result, and of course this is a little bit in contrast with the other thing that we knew what we wanted to achieve. We wanted to recognize type of cookies, but in this case we're trying to create structure from data that is we don't inherently know, essentially, the structure or the insights that we're trying to extract, but we can still do something about it. So, for example, if we start describing these cookies, what is their shape? Is it circular? Is it rectangular? Like immediately you see that you can separate those those data points along this axis quite clearly, and you can add more layers into that split as well. You can introduce the color or the feeling. And then, like you will be creating clusters where, and you can add many more dimensions like that, but you would be creating clusters in this case, rectangular filled cookies, round and filled. But, like your data will start sort of be grouping together when they have similar characteristics, which might be of interest, to the specific problem you're solving. In any case, all of the time we're doing machine learning, and we're trying different things. Of course, what's important is we can always sort of assess how well these approaches work. So we're not flying blind in either cases, supervised or unsupervised. In one case, we do know the end result, and we iterate through it. This is how we learn. So we end up with like a system that is that percent accurate on the labels we have. On the unsupervised case, we still can say the data have been grouped together into close-knit clusters. So the distances from each other are small, and we have a way to say that the approach we're doing to learn is sort of converging into something that makes sense. So as I was saying, we're trying to traverse this sort of onion. We talked about AI, and there were different things over the years. ML became the thing we're doing nowadays from 1990s onwards. Deep learning became just one way to do ML, which had to do with neural networks. We're not going to talk about that. But this led us to GenAI, which is just one aspect, one instantiation of machine learning. And as we said, GenAI is kind of like that subset that instead of sort of predicting, you're going to take a loan or this cookie is custard and things like that, is generating, text and content. And it's worth keeping in mind that GenAI also, contrary to these other things we've said, is quite general as well, in that it can generate, the text and the labels and, of all the different problems we were discussing before with the same approach. But how does this happen is a good question. So, as I said, GenAI is, we're generating lots of different types of content, and you probably interacted with one more than others. So, when you're, using ChatGPT or Claude or, your AI of preference, you're probably interacting with a generative AI model that is generating text. Of course, nowadays those again are collapsing together, and the same models that are generating text, you can say generating images as well. But all of which is to say that the large language model part was kind of like the text part of the GenAI puzzle, and there were other puzzles as well. And so the way these LLMs and learn how to do that is basically by being trained on a lot of data that we've provided. This is web-like data, the books we've written, and what they're trying to do essentially is as we said previously with supervised learning, when we're trying to predict, what type of cookie it has. Like in this case, all we're doing is we're just trying everything we've written, and we're just trying to get the model to predict, the next word on, the text we've written. So this looks a little bit like, if you go to the next slide, we give, when we use the model, we sort of give some sort of, prompt or words, and then there is basically a prediction on what comes after. And this happens both when you use the model, but it's what happened when the model learned. So when the model learned, it sort of took like a book, and it sort of saw the first sentences of the book, and then it tried to predict the next word. And as we said previously, like in the beginning, it wasn't predicting the right probabilities, and slowly it started learning what comes after. Now, after, so yeah, as I said, like this, the way this works in the LLM case, so we're generating text, and it's not very different from, like the other GenAI use cases. Is sort of we're generating word by word in the same way we've learned, right? So we're generating the next word, and then we're asking the model again, what comes after, and this creates a coherent sentence, hopefully. But a good question at this point might be, like how is it that process that, we're giving it all this text and, we're just predicting the next word. Is that enough of a process to sort of learn anything, right? Like, because previously we were teaching, like this biscuit, it was a particular type of label. I mean, it was very much, like we were controlling the task essentially. We knew what we're trying to achieve. Whereas here, the way we're training all these large generative AI models, it's a little bit abstract. But a good thing to keep in mind is that sometimes, in order to predict, not sometimes, often when we're trying to predict the next word, as you can see in this example here, then you do need to have some sort of complex world understanding, so to say, in order to be able to say, if if it's a continuation of a math problem, or if it's a continuation of, like a novel or something similar, then the next word um, is not disassociated with the meaning that whatever came before contains, and solving that next token problem is the sort of a nice simple task that, in order for it to happen, you do need to create something to some extent intelligent. Let's not say, like same as us, but like it needs to have some sort of human-like or world and human-like intelligence or world-like understanding. Cool. I think that's the last slide from me.
Yes, thanks so much, Nick. So I think with that understanding that what's happening with these generative models is that you're predicting the most likely next a word or pixel in an image, you can begin to understand why you get some of the risks and limitations of certain models. So we're going to talk a little bit about some of those risks, and we've broken them up into kind of two sections. One is around like environmental and social risk, and one is around the technical risk. So I'll tell you a little bit about some of those social and environmental challenges. So the first, as I think many folks in the room might be aware, is that there are, of course, energy consumption costs associated with the entire generative AI lifecycle. So, this starts from producing the raw materials in order to create the infrastructure and equipment needed to train and run these models. The model training and deployment themselves require lots of energy and resources, and then the data centers, as has been in the news as of late, that house the data for the training also need a huge amount of electricity and water. I would say that it's quite difficult to know the true cost of running any particular model or doing any particular task, because this isn't transparently reported. There have been some specific studies, one finding that training GPT-3, which is an earlier version of the model that underpins ChatGPT, used as much CO2 as about 150 people in a year. And a recent estimate put the amount of energy used for asking ChatGPT a query at about 6 to 10 times more than a traditional web search. So we know that these processes are very energy intensive, but we don't necessarily know in detail how energy intensive they are for different use cases and with different models. So what can we do about this? I think there's things that we can do as individual actors and then more collectively. So I think the first thing we can do is consider whether your proposed use case is a good use case for generative AI. And there might be much less resource intensive methods for achieving the same end goal, such as web search, which we'll talk about a bit later. If you do use an LLM, you can use a smaller LLM, which requires less input to train and less input to run, and is therefore less resource intensive. But I think more broadly, a key mitigation is to advocate for and incentivize transparency, so we actually know how much resource the usage, the maintenance, and the development of these different models and the infrastructure to run them takes. And then this can be used to ideally incentivize or potentially demand from tech companies that the algorithms become more efficient. There's been some great kind of initial work in this area. There's a recent piece by the Friends of the Earth team that looked at 7 principles for thinking about responsible AI use in an AI context. And there's some great work from the climate team at Hugging Face as well, if you're interested in learning a bit more about this. Speaking of the Hugging Face team, they host a open LLM leaderboard, which reports the CO2 costs of many different models, which is interesting to sort of see, how they perform versus how resource intense they are. And they've also been involved in a recent challenge called the Frugal AI Challenge, which is trying to look at how much energy consumption these models take, and therefore trying to incentivize developers to keep efficiency in mind and keep the models as small as possible. I think that the key is really transparency, so that developers and users can then make informed choices. I think it's also important to mention that there is a human cost of AI. There's an impact on workers. So as Nick talked about before, many AI systems learn by finding patterns in data, but that data has to be labeled by people first so that you know the crucial difference between a custard cream and a bourbon. And there's a job in the world called data annotation where folks, workers label data. This can be fairly innocuous in the case of labeling biscuits, or in labeling pedestrians in video footage for self-driving cars, but it can also be quite distressing. For example, if you're annotating whether messages on social media contain hate speech or not, or rating two different outputs for like explicit content from a chatbot. And because there's a significant human resource needed to do this work, many companies have turned to cheap labor, often in the global south. And I think, again, that the challenge here is that there's really very little transparency about how many people are employed in this way, very little transparency about their working conditions, and then what they're being asked to annotate. So again, what can we do? Again, I think like the first thing to think about is like, what is your use case? Is this can you justify your use case of generative AI? And we'll talk a little bit about that in the next section. And then if it is, like, consider your capacity to embed ethical reflection throughout the life cycle of the project. Again, I think it's really important to support transparency. Recently, like in the last year, there's been some work from Fairwork, who have developed some AI principles to look at assessing working conditions behind different AI systems, and they're now in the process of kind of benchmarking organizations on the basis of these principles, which I think will, again, make it easier to make informed decisions. We are going to dive into this in a bit more depth at our next webinar, but if you are interested, I can also recommend some of the work from the Merle Tech Initiative, who looked at, they posed a question: is it possible to procure an ethical AI tool? And at least from their discussion, they concluded that the best we can do is identify the least bad option based on the mission and the values of your organization, which is going to vary, and then continue to evaluate and improve its use. So those are some of the kind of social and environmental risks. I'm going to pass over to Michelle now, who will talk about some of the technical risks and challenges that come with use of these tools.
Sure, thank you. So I'm just going to talk about some of the key technical risks, and in the end, I will also talk about a little bit about guardrails and some of the mitigation methods for these. So the first thing is ChatGPT. I've seen some surveys that show that people are using it as a search engine. It's not really the best use of generative AI. For a couple of reasons, hallucination, which I will talk about in a second, but also there is a knowledge cutoff date. So for GPT, the latest GPT-4, I believe the knowledge cutoff date is October 2023. It means that if you want to ask it about current events, it may or may not know the answer. It might give you an outdated answer. So if you ask how many stamps you need to mail an envelope, it'll use the postal rates from 2023, for example. Or if you ask about an API call or technology that was introduced in the past year, it won't be able to know about it. There are some search capabilities that it has. So if it'll, I guess, try to use the search engine connection to look for more up-to-date information, but it's can be quite unreliable based on my experience. Sometimes it'll use the search engine, sometimes it won't. So that's an important thing to note, that the information that it's provided is not up to date. Not up to date, and its search engine capabilities are not always able to correct an outdated piece of information. Next slide, please. Yeah, and then I think everyone at this point hopefully knows that LLMs can hallucinate, but you can never be too sure. I think there was a recent Deloitte survey that showed that 43% of people in the UK believe that generative AI is always factually accurate. So those are kind of scary numbers to be hearing still. But I think there were a couple of high-profile cases of this where lawyers were using ChatGPT, and ChatGPT made up some random case precedents, which ended up as a part of the court filing, and the lawyers were fined, and this was all over the headlines. This happened first in New York, and then clearly the someone didn't like read the news and learn about it. So because this happened again in Canada. And I think it is important that there is human in the loop to check any sort of factual accuracy of what is coming out of generative AI systems. I will talk about how to mitigate some of the hallucinations from a technical standpoint, but just to be clear, a lot of the mitigation techniques that I can discuss later are more for technical development using generative AI systems as kind of building blocks to a solution. There are some things you can do with kind of open access tools, like just logging onto ChatGPT, but it's like a lot of the guardrails apply more towards like kind of the custom build situation. Next, please. Yeah, so I think one of the most difficult parts of building LLM solutions is that there aren't as easy of key performance indicators like KPIs as it is with supervised machine learning, for example. You can clearly calculate accuracy, precision, recall, but if you say, summarize this document for me, how do you then quantify how good that summary is? It could be based on like how well written it is in terms of like no grammatical errors. It could also be these are the 5 key elements in this document. Did it get all 5 of them? Or it could be, have you represented the facts correctly, like and in an unbiased way? Or it could be, or it could be like, did you make any statements that are like factually inaccurate? And I think all of those are kind of different checks. And there were some studies that show that the accuracy of summaries can be quite poor, and there were some significant issues with the summaries that were provided. So that's another one to be aware of. Don't always trust the summaries that LLMs give you. If you're uploading a PDF and it pops out a summary, it's still worth going back to the original document and checking. Next, please. This is a pretty well-known problem in terms of math. LLMs haven't been the best at math and logic at times. I think there's a popular one that's like, how many R's are in strawberry, and it'll keep saying 2. And similarly, if you're asking kind of like more math style questions, LLMs may not be the best tool for it. So in some of the solutions, for example, we utilize different, if it's a math challenge, then like the LLM would pass it on to a different API call, like Wolfram Alpha API or something like that, that are built more for math rather than languages. Next, please. So this is just one of the news articles, one of the many news articles that I've seen. There was an Asian MIT student who uploaded a photo of herself, asked it to turn it into a LinkedIn profile photo. And instead of just putting her in a suit and adjusting the lighting, it just made her whiter and said, here's a professional version of yourself. I think there are a lot of stereotypes. There's a huge article that you can see where like if you ask it to produce generative AI images of housekeepers, janitors, more kind of blue collar workers, it'll mostly show kind of minority faces, versus like if you ask for like a lawyer or a doctor or a professional, it'll more likely to be white men. And I think these are the kinds of stereotypes and biases that are being embedded in these systems. And if you talk about a doctor and a nurse, ChatGPT will often assume that the doctor is a he and a nurse is a she. So both in language and in images, there are some biases and stereotypes that can emerge in unexpected ways. So if you're using it for something like, I don't know, CV screening, just be aware of the potential biases that you don't want in there, skewing the results in some way. Next, please. And these are just some of the other risks and challenges that people are all talking about in terms of deepfakes, copyright issues, especially for producing art or writing articles. And then there's user buy-in issues in terms of when you're talking about LLMs, there's still a lot of hesitation in terms of using AI systems. And I read an article actually that women tend to be more skeptical of generative AI technologies than men as well. And then training in terms of what kind of new skill sets do people need? Because people whose job it used to be to like read thousands and thousands of pages of documentation has a specific kind of a skill set, but now that generative AI can produce kind of first draft versions of summaries, for example, they become less of content creators and they become more of like, I guess, content reviewers. And does that require a different skill set in terms of prompt engineering and reviewing the material? And also, I guess, economic disparities in terms of these generative AI tools only being limited to organizations that can afford them. Data privacy challenges. I think this we will get into a lot more. ChatGPT doesn't have the same level of kind of privacy and security guarantees that the enterprise version has, for example, and that's something important to consider. Transparency issues. Although in terms of transparency and explainability, if you are building a generative AI-driven kind of solution, there are some ways around it in terms of getting confidence scores for the output, designing a specific kind of an architecture to enable like kind of citations and traceability of like this is where I got this piece of information. But that's again a little bit more for custom build use cases. And then replicability. I think this is one that worries a lot of people that there is, unlike in kind of other types of machine learning systems, there is an element of randomness and stochasticity in generative AI systems. That's kind of a feature of how it is meant to work. So sometimes you can get asked the same question and get different answers, which makes auditability and testing quite challenging. That can also be mitigated to an extent. From a technical standpoint, there are some parameters that you can change, something called temperature. There are prompt engineering techniques, and usually when we custom build a solution, we also include kind of error logs and conversation logs to make sure that we can trace back anything that went wrong. Final one, I think, from me is this is the generative AI guardrails that I was kind of referring to earlier. When we're building this is what's called like a RAG architecture, which is not super important to know, but it's essentially chunking up a big amount of text documentation and including it as like a part of the context in your prompt and your query. And there are a lot of things that you can do, but I break it down into 4 things. First is input control. So if someone tries to upload document watermark confidential or tries to send personally identifiable information over the tool and it's not really meant to, then it'll automatically block it. So I'm talking specifically about a tool that I had built in-house at work. So it'll automatically block it. In terms of prompt engineering, that's giving the end user like a much simpler kind of UI to say, I want this to be focused on like the risk side and be like conscious of downside, or I want this to be more focused on kind of like upside potential and be very optimistic. Like that's kind of the tone of voice, right? Or you can say, what level of detail do you want? Do you have examples of like what's a good answer and what's a bad answer? And these are all different kinds of prompt engineering techniques to try to get the best possible answer out of the large language model possible. And then output control. I can talk about it in the case study, but essentially making sure what comes out of the LLM isn't uh, discriminatory, inflammatory, or anything. And also, if it's an enterprise tool, make sure that the end user has access to that piece of information. So depending on who's logged in. So I work in private equity. So if one deal team doesn't have access to another deal team's memos, then we need to make sure what's in the output doesn't reference anything from like the other deal team's work or whatever it might be. So output and access control. And then finally, human in the loop and feedback mechanisms. So this includes the knowledge workers making sure to go through all the citations, and if something doesn't look right, they report it so that we use it for further refining either the prompt or the model itself and the model parameters. So these are some of the GenAI guardrails for when you're building a GenAI solution in-house using an LLM API. Cool. I'll pass it back to you, I think.
Yes. So now we're going to talk a little bit about use cases for the third sector. I see that there's a couple questions in the chat, which are both really good questions. We will park those till the end, but please do keep the questions coming. I think that yeah, they're just a bit long for this particular section, and then we'll be able to circle back. So Nick's going to start us off about with some examples of how this might apply to the third sector.
Cool. So these are just to get us started. Two examples I actually use at work, which might be illustrative as how you can embed AI like in everyday tasks. So when I used to write content for my business, I used to have like a flow where I had to read the news, I had to sort of understand them, summarize them. And then I had to go and publish them. These sort of whatever news sources I was using, of course, they were written from journalists or researchers, what have you. Nowadays, I actually have an AI generated newsletter. So this is an AI agent that sort of goes into Twitter, the web, various sources. Reads all the news there is and then summarizes everything and then automatically sends you a newsletter. So this happens every day. So I read that, I take some pieces from it. Then I use another AI in the tool we have at work called Notion. So this is kind of like Word. And I say, okay, this is, what I'm trying to write. And these are examples of previous things we've written. These are the points I want to hit. And then it starts me with a draft, which I sort of tweak a little bit and then I can publish that. So content creation and also another sort of content related one would be a case study, but the case study one is interesting also because it's quite generic in the sense that in our line of work, we work with clients and all the information we have is in either the communications tools we use. So similar to Teams, we use Slack. Similar to Word, we use Notion, so we document everything there. And, we have Google Drive, same as OneDrive for the documents and everything. And what you can do nowadays is you can, connect everything into an AI system and then say, these are examples of previous case studies we've written. Can you retrieve everything we've done for this client from all these, channels and so on and so forth? And, draft a case study based on all of those, similar to the ones we've written before. And hold and behold, it does that, which you can again tweak. And interestingly, this needs to go to our website. So that involved me writing a little bit of code, updating the website with that case study, which is now also automated. So GitHub, which is kind of the tool we use to host our code, has an AI system on its own. So then I can say to that AI system, this is the text I want to update the website. It goes into the code, finds the relevant section, adds the code, and opens a pull request that I can again review. It rarely has any issues, and I can merge in the case studies. Like,
That's great. So we're just going to talk through a few more examples of content creation before talking about some other use cases. We've talked mostly about text-to-text generating models, but we referenced in the beginning the fact that you can do like text-to-image generating models. And I've seen some interesting examples recently from different organizations using this for advocacy and campaigning. So this is an example from the World Wildlife Foundation, who used AI to create images depicting what the world would look like in 40 years under different scenarios. So one, if no action was taken to preserve the earth, and one, if we took their recommended action. And this is interesting. I think it can be a pretty powerful tool for advocacy to create, images or worlds that you couldn't otherwise visualize, but it has not been without its critics. So one, of course, is around copyright and plagiarism, which has been raised by artists globally. Another, though, is around credibility. So the WWF example was perhaps less controversial, but another human rights organization used AI generated images to depict protests and police brutality. And they had incredibly good intentions here. So their goal was to preserve the anonymity of the protesters. But some of the critics were worried that using AI generated images could undermine the credibility of advocacy groups who were trying to counter arguments from the governments that their footage wasn't real. So again, I think it's very use case specific. You really have to think about the specific ethical quandaries of your use case. And in terms of mitigation, I think always keeping the kind of human in the loop for review, thinking about the ethics around your specific use case, and then transparency, being transparent about what you did, what you used, and giving credit in that way. I think, as many folks here mentioned in the initial survey, generative AI is also being used for fundraising. And I think up to about 20% of nonprofits now are using AI to help with grant writing and do other fundraising tasks, like providing specific targeted outreach to prospective donors. And there's been some tools emerging that integrate this, like Plinth. I think in terms of risk, some things to be aware of here are data privacy and the risk of sharing kind of your operational and strategic data with some of these tools. So you need to read the privacy policy. We can't kind of go into the specifics of each tool, but be aware of how the tools are using the data, whether it's used for training of future models, how the data is shared. I think another challenge that maybe isn't being raised so much, though, is around funder overwhelm. I think those of us who work in charities know that funders are already getting more applications than they can possibly process. And so how are we as a sector going to deal with the use of the AI in generating funding applications if this is just going to further add to the burden and delay processing time? And then the third risk is around plagiarism. So the data sets to use to train the models underpin all of these different tools. As Michelle mentioned, like we honestly don't know what the specific data sets are a lot of the time. Most of these models gather huge volumes of data by scraping the internet. And just as an example, like the New York Times have sued OpenAI and Microsoft and alleged that the data that powers ChatGPT and Copilot includes tons of their copyrighted data. I think we haven't really resolved societally how we're going to deal with this issue. If it's usually not verbatim plagiarism, but how do we mitigate that? So I think that's something that organizations and individuals have to wrestle with.
Cool. So the three use cases that I'll talk about were a part of a genAI for Good hackathon that I had organized, where we helped two charities, Just Like Us and Young Women's Trust, with some of their data science challenges, and we got together a group of volunteers who wanted to use generative AI and use their like corporate volunteer day to do something interesting because we're all data nerds. And one of the ones that we created was by request of Just Like Us. How do we identify potential corporate sponsors that are similar to the successful sponsorship and partnerships that we have right now? And so the solution was kind of threefold. The first is scanning public feeds. We had because it was just a hackathon, we got Twitter data that was already scraped to identify brands that have talked about diversity, LGBT plus issues, and for example, posting frequently on Pride and things like that. And we built a clustering model to cluster similar brands together based on kind of shared values and characteristics, and what are their kind of target audiences normally. And then they were also like interested in understanding like LGBT plus owned brands, for example, and then use the large language model to look at the latest annual report and draft an email to a brand to propose this partnership. And I think this is a good example of not just 100% relying on the LLM. Some of the most powerful use cases come from combining more traditional supervised machine learning and unsupervised machine learning algorithms together with a large language model to build kind of an end-to-end solution. Like if you don't have to use an LLM, it's best for explainability and also, I guess, reliability to use more traditional machine learning models like we did here. I guess the risk here would be any sort of inaccuracy, but this was completely with human in the loop. This was for the guy who was usually doing all of this manually and helping accelerate that kind of search process. Next slide, please. I think next one is Young Women's Trust. This was to build a prototype of Ask Wendy, which was to help young women who are looking for a job prepare for their interviews. We actually spent a lot of time on prompt engineering. Like, so for example, if one of the interview questions like, oh, tell us about your strengths and weaknesses, and then the young woman would try to answer it, and then based on that answer, it'll provide like kind of a constructive critique of that answer. But we needed it to be the tone of voice to be more empowering to the woman and not too overly critical, for example. And there shouldn't be any kind of gender assumptions in the answer either, in terms of saying like, I guess, assuming the interviewer is a man, for example, or anything, or like using any sort of gendered language in the output. So there was like a bit of a guardrail development as well as prompt engineering to build a prototype of Ask Wendy.
Yeah, so there's been a number of chatbot prototypes and some even into production. And I think that, yeah, Michelle's done a great job explaining some of the guardrails. I think another example of a chatbot, not so much in the service delivery, is for internal knowledge management. And some folks here might have heard already about the tool developed by one of the citizens advice teams in Greater Manchester. They were recently on Sky, I saw, and they built a tool called Caddy, which is a bit of a co-pilot for their advisors. And the goal was to help them more efficiently locate and share information from reliable sources. So I think probably everyone here is from the UK, but just in case we have international folks who don't know how citizens advice works, it's a service where we can call in and get advice from a human on a variety of issues. And normally the advisors have to go through and gather information from all sorts of internal documentation. But with this Caddy tool, the advisor can input their question into the tool, and then the tool will look at answers only from verified sources. And then the answer itself is then also reviewed by a supervisor before it's sent back to the advisor and then summarized to the client. So it's not a client-facing tool. I think that the citizens advice team have been like really thoughtful about how to put in human guardrails to mitigate the risk of hallucinations. It's obviously like very crucial that this is not wrong basically ever in this instance when you're giving people sensitive advice about like their unemployment claims. And there's, risks around bias in the answers and that kind of thing. And so I think the other mitigation that the citizens advice team had to build in as well was in training and making sure that the advisors were confident in asking questions, because like the quality of the prompt definitely would affect the quality of the answer. The other example that we've seen recently is around using GenAI tools to support with case management. And one of the examples that I've seen is around helping auto-summarize case notes and also help with prioritization of cases. Help First are a small organization who are building tools to support with this. I think that there's many risks that need to be mitigated with some of these tools. Of course, like bias and fairness. So as Michelle talked about, the models that underpin many of these tools inherit biases that exist in our society and therefore exist in the data that's used to train the models. And so there's a huge risk that that there could be kind of like unfair treatment of certain client segments. I shouldn't say huge. I actually don't know how big the risk is. It would depend on on the model, but there is a risk that there could be unfair treatment. And there's also a risk of model trust with like frontline staff trusting the tools, potentially not wanting to adopt them. So I think that those are things that you need to build into the process, and also make sure that the outputs aren't biased by doing explicit testing. We've also seen a lot of interest in how GenAI can be used to analyze survey data. And this is a question that 38 Degrees recently tackled. And actually, I think I saw Nathan in the audience. So if people do have questions, you can ask them directly, which is great. So they wanted to evaluate the public's opinion on NHS surveys using survey data from their supporters. And they used two different LLMs to help them do a thematic analysis of these like free text questions. So this was with Claude and ChatGPT. And the goal was to create like a narrative on the public perspectives. So this enables people to do analyses that might have traditionally relied on like more technical text analytic techniques that many charities just don't have the capacity or skills to do. Which is exciting. But they did encounter some risks and that they had to, and challenges that they had to mitigate. So one was a kind of around hallucinations. So where there's like plausible sounding output, but it's actually not real. So this they mitigated by iteratively testing and changing their prompts and seeing how the output improved. But in the report, they also mentioned that the model struggled sometimes with like coding the responses. For example, if somebody had just written 100% in their response about NHS services, a human would probably code that as like this person generally approved, like general approval. But the model sometimes struggles with that kind of coding. So I think for this use case where they were trying to make a cohesive narrative, it makes sense to use these tools. But if you were, if it really mattered to you to know the specific course themes, like if you care whether 15% of the responses are about topic A and 18% are about topic B, then those are things that you're going to need to check and test in the output to make sure that the model is performing as you want. And then, of course, with any free text data, you need to ensure that the personal data is protected and then not shared with third parties unless you have consent to do that sort of processing. And then the last example I think that I will mention is around conversational data analysis, which I think is a really interesting and a new approach. So this is actually an example from our colleagues at DataKind Global. They wanted to build a tool that would enable non-technical people to get insights from up-to-date humanitarian data, which came from a portal called the Humanitarian Data Exchange. And so they built a tool that is built on the idea of chat with your data, which for technical folks came from like the Lang chain, which allows you to chat with your data through SQL queries. But this was slightly different insofar as you asked the chatbot tool a question, and then it goes and generates code that has been verified by a human, and then uses that code to answer your question. So you could ask the tool something like, "Can you create a bar chart of refugees' final destination from Sudan?" And it pulls in the relevant data and then makes the relevant graph. So I think this is a kind of interesting new avenue that could enable more people to be able to get insights from data without necessarily having technical skills. But there are challenges around the kind of transparency of what's happening behind the scenes that can be mitigated with things like human in the loop review of code.
Yeah, I think this is the last case study. So de-identifier was another solution from the hackathon for Young Women's Trust, where they had a lot of manual work to put like black boxes over like personally identifiable information. So this is a solution to automatically remove personal information from PDFs of like CVs. Using open source packages. So this isn't using large language model or sending information anywhere. It's just like looking for specific things, like name, phone number, and things like that. And the other thing we did was use a large language model to flag something that's not technically a personally identifiable information, but something that could identify someone in context. For example, if someone wrote I ran the London Marathon and here's my marathon time. You could, I guess, in theory, go and look that up. Or if someone says, oh, here are like all of my publications, you could go on Google Scholar and look them up and things like that. So that's just to, I guess, warn the person who's anonymizing it. Here are some pieces of information that could identify someone, and then like let them decide whether or not to further anonymize it. Cool. So I'm going to talk a bit about some of the types of generative AI solutions and how to add in some privacy controls on things like ChatGPT. Next slide, please. So this one, I think a lot of times people talk about third-party GenAI versus in-house built GenAI, but it's really like a lot in between. I actually wrote this article, and like the link is below this, on like the different requirements for third-party risk management for different kinds of like combination of third-party Gen AI. So when we talk about something like ChatGPT and Gemini, we're talking about open access solutions, ones that may or may not need a login, but you don't need to like you don't need like an enterprise level contract or anything. And then you also have like kind of enterprise Gen AI where that's like enterprise version of ChatGPT, for example. And then often when we talk about in-house Gen AI, it's still using a lot of third-party components. So using ChatGPT's like GPT-4 API as building blocks to build a specific solution. So you do have to be concerned about some of the supplier risks and some of the third-party risks of using that API call. The only thing that's like really fully in-house, I guess, would be either open source packages that are run without any kind of reliance on third-party APIs. So that would be things like Llama 4 or any of the ones that are publicly available. Or I haven't really seen people do this very often, but like custom building a large language model from scratch. It takes a lot of processing power. I've only seen this done really at a pharmaceutical company where they have a lot of patient data, so they obviously didn't want to send information to a third party, so they were exploring in-house Gen AI solution development for their own use. Next slide, please. And then this is like just, I guess, examples. Third-party open access ones are like OpenAI, Gemini, Claude. Hybrid enterprise versions are like enterprise version of ChatGPT, for example, or Azure. And then in-house example would be something like Hugging Face. Next, please. And then in terms of how ChatGPT uses your data, I think we get this question a lot. They're using, this is kind of what they have on in their disclaimers. They're using the data to train their models and improve services, but you can opt out. So in the, can we go to the next slide? So I just screenshotted it from ChatGPT. If you go into settings, you can turn it off and improve the model for everyone. And then you can also turn the memory on or off depending on what you're looking for. And then if you actually click on manage memories, you can look at all the information it's stored and then delete some of them and keep some of them in. Sometimes having a memory is very useful because it'll remember a lot of the context and give you information that's more specific to you. But it like if it can like retains information you don't really want in there, it's useful to kind of go in and like delete the memories or just prevent it from storing any memory. For a ChatGPT enterprise version or anything else like that will just depend on your enterprise contract, but the additional layers of protection tend to be like encryption at rest and in transit of all the information and not storing your information at all, like for training purposes or anything else. Yeah, so I'm not, I guess disclaimer first, I have no legal background and I have no like regulation background. I just did a little bit of because I worked on a lot of like risk and reg use cases, I just have some familiarity with it, but definitely refer to someone who's more of an expert than I am if you have any specific like privacy or law questions. But I think the rule of thumb is do not share personal data in like open access generative AI systems, and be careful what you share in your prompts, in especially, I guess, personal information, and conduct any sort of risk assessments. I've seen people do like add questions to their DPIA that are specific to generative AI systems, for example, to embed it as a part of their risk management process. And then I guess consent, um, ensuring consent for use of data in a specific way, although I think GDPR doesn't necessarily like require consent per se. It's probably like, so for example, like I guess for fraud detection, where there's like reasonable expectation that your data will be used in that way, you don't necessarily need informed consent. But I think looking for the foundation for like I guess a legal basis and legal foundation for using that information will be important. Considering running models locally, I guess this one is an interesting one. I think for companies that are cloud-based and have information in the cloud, I don't think there's like a huge difference in security if you then use like Azure services like enterprise tools, because like your data is already in that cloud and then it's the GenAI system that's using the data that's already in there. But if you are not a cloud-based if you are not cloud-based, then I guess there are some use cases where it might make sense to use the open source large language models and run it locally. But I think those cases are getting rarer and rarer these days. Yeah, and then finally considering enterprise tools, enterprise versions of different Gen AI solutions.
That's great. Okay, so just to wrap up, and we'll tackle some of these questions. How do we get started? We think that it can be helpful to think of generative AI in the context of your organization's broader data journey. So, in thinking about how you or your organization might want to get started using these tools, think about your overall data maturity and the capacity of your organization. I think this is helpful just to think about any kind of foundational areas that might need supporting, whether it's like your internal data quality or your capacity to think about ethics, just to ensure that kind of any tools that you build aren't built on sand. It's helpful as well to think about guidelines or policy. I think, you could start as simple as thinking about where are the no-go areas for you and your organization, and what other values does your organization hold that need to align with any like vendor procurement. As always, you'll hear us say this in every data talk, like start from the problem. Consider what your challenges are, and what challenges you have in achieving your organization's mission, and start there. And that will increase the chance that any use cases that you have like really do add value. And in terms of justifying your use case, like our recommendation is that you really consider like a specific use case, and you know your goals and vision. Consider the risk. So like generating code that's going to be reviewed by a person is a fairly low risk task. But having an AI agent do personalized service delivery, I would say, is a high risk task. So think about like do a risk assessment of your use case. Think about what guardrails can be put in so that you can proactively mitigate risk. And then finally, talk to your peers. There's a number of communities and places where you can meet other folks like working in this space. We have one coming up for people who are in the beginning stages of prototyping a chatbot, but the folks at CAST have an excellent digital leads network, and the AI4C group also exists and runs various events throughout the year. We've included some of our resources, and all the links are also available in the slides. And just before we open it up to questions, just a few housekeeping things. First, we really hope that you got value out of this webinar, but even if you didn't, please let us know. Please fill in our feedback form, because it helps us, the impact that these events have and what you want to know next. It really helps us continue to develop them for the future. So I think Nicole will pop the link to our feedback survey in the chat. And please do follow us on LinkedIn if you want to be kept up to date with our future events, or join our mailing list. We have another webinar coming up in a few weeks around responsible use cases. So if there's a use case that you want to know more about and talk more about guardrails, let us know. We're going to be diving into that with some more experts in April. And we have a few more days open. If you are in the stages of thinking about or prototyping a chatbot for your third sector organization, and you want to have a small facilitated peer group discussion, you can learn more about that at the link on the QR code here. So just before questions, just want to thank Michelle and Nick for their time, and everybody here for joining the Insight Infrastructure team. And I'll stop sharing my slides, and we can go to some of the questions that are in the chat. Okay. All right. So let's just start from the beginning. We've got a question about open source. So we suggested using open source generative AI. What is open source? And I think maybe just we could start with like, what's the difference between open source and open access? And are these reliable and data safe-ish? This person is just aware of Copilot, ChatGPT, and Gemini. So Nick or Michelle, either of you want to jump in on this one?
Happy to jump in. So these examples that are mentioned are all closed source, but there are equivalent models for all of them in the open source domain. As we mentioned, Hugging Face is sort of a repository of those models, but you can also find them in cloud providers. So AWS has, Bedrock, and it offers some sort of models that are open source, like Llama or Mistral, or equivalent. And Azure has the Azure Model Registry, I think, like that offers similarly like access to Llama, possibly Mistral. There are different levels of openness. Of course, some of them are open in the sense that you can use them, whereas others are, completely open with the data that they use. There is the most open approach is from Allen AI, so another charity, where they've open sourced the code, the data, they made sure that the data is sort of, removed from sensitive, like that they have the rights to the data and removed from sensitive information and so on and so forth. But for example, Llama or Mistral, you only have access to the model itself, not the data it was trained, neither the code that was used. So different levels of openness. But otherwise, so it either depends on you, on how you use that model. So if you put it in your own infrastructure, you are, um, it's as safe as your infrastructure is. And similarly, if you use it through these providers from the cloud, you're relying on their security. I think so. Llama itself is not offered from Facebook, the developer, as a sort of service, but Mistral, as an example, is also offered from the company that develops it. So look, the data is as safe as the privacy policy of Mistral if you use it through them. Anyway, hope that answers the question and helps.
Thanks, Nick. Yeah. So I think in general, like open source means that you can use or modify or redistribute the code, but the level of openness varies. And some folks say that like if something's really open source, you need to know all the data it was trained on, and the code and the model architecture and weights, which we haven't really got to yet. But Hugging Face, Llama, Mistral, we put those in the Q&A answer. So that's great. So the next question was for Michelle. So you mentioned a bit about the guardrails that you can put into your infrastructure or architecture. Is there like a single tool that allows you to put these guardrails in place, or is that like a standard feature? How would somebody go about doing that?
Yeah, for open access tools, there are some standard guardrails that are added, like already included. So if you ask, I think Gemini for medical advice, it'll say, "I'm not a doctor and I can't tell you that." That's an example, I guess, of an output control. Um, but I think the guardrails that I mentioned are more for if you're building your own kind of GenAI solution using GenAI APIs, so the large language model APIs, then you can build in some custom guardrails. There are some open source guardrail libraries that you can use to, like, I guess, get started. I think the most famous one is from NVIDIA. It's called Nemo guardrails, and those can be kind of coded into your platform. But some of them my team like custom designed them, things like specific access controls and looking for a specific piece of information that's not supposed to go out and things like that.
So just to follow up, like, is it fair to say that like if you're using open access tools like ChatGPT and Gemini, like your main guardrail is like in your behavior and like how you use the tool in terms of what you share and like how you ask the question. Whereas if you're building your own like internal chatbot, then you can embed different guardrails using different tools throughout the process. Is that fair?
Yeah, exactly. And for open access tools, like the guardrails are there for um like some people like guardrails are there and you can't really like I guess control it all that much. Because like and some people say, oh, the guardrails are too extreme, or some people say it doesn't go far enough, but like there's no real way for you to like turn it on or off, I guess, in things like Gemini or ChatGPT. But there are prompt engineering techniques that you can use if you are concerned about something specific.
Okay, that's great. So I'm just going to go through these in order. This is a quick one. Is limiting access in ChatGPT limited to paid for services, or can you do that in the free version as well?
The screenshots that I showed were in the free version, so that was just from my login.
Perfect. Okay. So this is a question, there's like kind of two questions that are a bit tricky, and I would say that we none of us are legal data professionals. So we are therefore limited in like how much guidance we can answer around like data sharing policies. But there's kind of questions about like how would you go about writing GenAI use into a data sharing policy? And a question about like if I ask participants from a focus group if they agree to me using AI to analyze their responses, like I think the question here is like, is that okay? There's probably examples of this. Do either of you have thoughts on this, these sorts of challenges?
I mean, it's probably whatever you already have in terms of data sharing policies and then kind of adapting it for generative AI. Like what can you and can you not share with open access platforms, for example, like no company confidential information, no personally identifiable information, etc. I've seen that like kind of a blanket ban, for example, and like open access um, generative AI systems if the company has like an enterprise version that they want everyone to use. So, for example, Deloitte has something called Paired, and that's an in-house only version, I guess, of ChatGPT with a lot more guardrails and a lot more like I guess enterprise grade security in terms of all the data. So I guess it depends on what tools you're comfortable people using or not.
Nick, is this ever a question that you get with any of your clients around how their data is being processed?
Not really. So we provide the service, of course, to the clients, and then they have to incorporate some sort of something into their own privacy policy or what have you. But I wouldn't say it's very. They would have to be doing nothing with data in order not to be covered with how GenAI is used. I think, but again, as you said, not a lot.
Yeah, I think we can try to tackle this a bit in our upcoming session in June around building AI policies, because I think it's a challenging question. Okay, in the last minute, what are your thoughts on DeepSeek? So DeepSeek is a new smaller model that was recently developed in China in terms of performance, but also concerns from a voluntary sector perspective. It's a hot topic. Either of you up to
I
date
can
on?
share a piece I've written in my blog, but from my side, in a nutshell, I think it depends a little bit what is your angle. I think you might be thinking something, like is sort of China better than the US, or well, what gives, and DeepSeek sort of came to be. But DeepSeek itself is, like another open source model that is quite capable, similar to Llama or Mistral. So, you can use it without fear of, your data being, so first of all, there is the equivalent of ChatGPT. This I would be a little bit skeptical to use because, your data might not be as safe as it seems, but the model itself, which I don't know if it's offered in the cloud infrastructures now, but you can, it's open, so you can take it and change it as you wish and, host it, and it's a very good model. So that's that. And, a little bit on the sort of buzz that came with DeepSeek from my side is some of it is a little bit um, misguided in that, there's a lot of conversation about how it's being trained with, like with a small budget and things like that. That's not entirely true. That said, there have been a couple, it's quite cheap to run. OpenAI dropped the prices, so it's not, as cheap as it was when it launched. But in any case, there were some breakthroughs in using the model quite cheaply, which is open source. So there is some kudos there, but not necessarily to the fact that it was trained with a tiny budget. That's not entirely true.
All right. Well, thank you so much, everybody, for the questions and your engagement. Thank you, Nick and Michelle, for your time and expertise today. And thank you to the infrastructure team at JRF for supporting this. I hope to see many folks at our next session on April 2nd. Please let us know if there's any specific use cases. And please fill in our feedback survey. It really helps us understand how to shape the content for these webinars. So enjoy the rest of your afternoons.